Okay, so this Revise With Me video is for higher tier and we're looking at congruent triangles. When you look at a pair of triangles, to decide if they are congruent, we're looking to see if we have matching sides and angles. Congruent is the mathematical word for identical, so they would have to have 3 identical sides and 3 identical angles. Most of the time in exam style questions, the triangles will be drawn from a different orientation. So as with this one, we can see features that appear to be the same, but the orientation of this second triangle here makes it difficult to find corresponding sides and corresponding angles. So if I draw that triangle facing the same direction as the first one, then I can put the 3 corners in place, corner M, corner N, and then corner L. I can see that LN is 15.5, because LN being 15.5 is taken straight from that picture there. And corner N, I chose to be here so that it corresponded in location to corner B. So LN corresponds to AB, corner B corresponds to corner N. Looking at my 2 diagrams now, I can see that for this first question here, write down the length of MN. On my picture, MN is across the bottom. So on my second triangle, it would be across the bottom, 9.1 centimetres. Part B, where it's asking me to explain why angle A is equal to angle L. This is a little bit like a mini proof, so bear with me, the language is quite particular. As AB is equal to LN, those 2 sides are the same length, and angle B is equal to angle N, the 2 angles are exactly the same, then we must also have angle A equal to angle L. Okay? So as AB, let's just highlight what my argument is, as AB is the same length as LN and angle B is the same as angle N, then it follows that angle A here must also be the same as angle L. We call it quite often angle side angle for short. Cool, question 2. Here in question 2 we've got a jumbled mess of triangles, and it says, shown below are 6 triangles that are not drawn accurately. Which 2 of the triangles are congruent to triangle A? Well, first of all, triangle A is missing that 3rd angle, but as they add up to 180 degrees, it's easy to work out that that would be 45. And now if I go for the pattern here, angle, side, angle, I'm looking for other triangles that have 64, 4.6 and 45. So I can see here the triangle B has 45 and 4.6, but 6.4 is in the wrong location. When I'm looking at triangle C, I can see that I have 64 and the 4.6, and the 45 would be here, which is the right location. So C is the same as triangle A. And then as I look at the next one, I don't need to do the calculations because I've got the 45, the 4.6 and the 64. So D. Just to check, E has the 45, the 4.6, but it doesn't have the 64, so that one's no good. And triangle F has the 64, the 4.6, but it doesn't have the 45, so that one's no good. So what I've looked for here is angle, side, angle, and congruent triangles have angle, side, angle, angle, side, angle, angle, side, angle. That's how I know which ones were congruent. Question 3, focusing on those conditions then, for each of the following pairs, state the condition why they are congruent. So this is what we now say. We say side, angle, side matches side, angle, side. So that gets called side, angle, side. It follows that if a triangle has two matching sides surrounding a matching corner, the other side and the other two corners must also be identical. So it's proof or a condition of congruency. If you have a look at part B, this time we don't have any angles, but we have side, side, side. So this follows that. If the three sides of two triangles are identical, so are the three angles. And again, congruency. Now for the third part, we have this time to work out the missing corners. 75 down here, and 75 there. And this time I can see that I have angle, side, angle, angle, side, angle. So angle, side, angle. Although they're in different orientations, they are a pair of congruent triangles. Question 4. James and Chris each draw a triangle with one side of 10, one angle of 45 and one angle of 85. James says that their triangles are congruent. Possibly, but explain why James is incorrect. Okay, so a pair of triangles have to have the angles and sides that are matching in the same location. So if we said that the bottom of each of these triangles was 10 centimetres, that would be a step towards congruency. But if we said the 45-degree angle for James was here and the 85-degree angle for James was there, but on Chris's triangle he did the 45 here and the 85 there, this would be a angle side angle. But this isn't going to have the same 85 degrees and 45 degrees with the side in between. So these pair are not going to be congruent. So importantly, my explanation is going to need to say we do not know the location of each angle. The two triangles above, these are my examples. Two triangles above are not congruent because they have to be in a corresponding location, and these two aren't. Question 5. ABCD is a parallelogram. Prove the triangles ABD and BCD are congruent. So you have to give enough explanation with reasons for there to be no shadow of a doubt that the sides and angles are matching. We want congruency. It's probably easier for a parallelogram to go for matching sides. So I'm going to prove side, side, side because of the properties of a parallelogram being similar to the properties of a rectangle. So I'll start off with BD BD was shared by both. So BD here. This is a shared line in both triangles, so therefore in both and equal. So I'll put, whoops, BD is shared. So in my two triangles, I've just proven one side's exactly the same. Then if I look at BA here and CD, they're the opposite sides of a parallelogram, so they are the same length. So ABA equals CD, and my reason, very important for the proof, opposite sides of a parallelogram, and that's two sides proven now. So I've proven side BD, I've proven BA is the same as CD, and then for the last and third set part of my triangle, BC here and AD for here. And again, because of the properties of a parallelogram, I can say that they are the same. So BC equals AD, opposite sides of a parallelogram. Therefore, ABD, the one triangle, and BCD, the other triangle, are congruent due to side, side, side. One of the conditions of congruency. Okay, so last question. Alright, so two of the triangles below are congruent. Identify the two congruent triangles and explain your answer. Pardon me. So we need some more details on each of these triangles. Some is more easier to fill in than others. For example, I know this angle here must be 60 because we're looking at a 30 and 90 already, but it's not so easy to fill in the length of the other sides. Now, I can use trigonometry to find the lengths of sides and to find different angles. So I'm just going to run through those quickly around the sides of the pictures before we look for congruency. So starting off by looking for the hypotenuse here. To look for the hypotenuse here, using my angle of 60, this would be the opposite, this would be the adjacent, and to find the we'll find all three, but to find the hypotenuse using the adjacent, we're going to be using cos. So cos of angle 60 is going to be the adjacent over the hypotenuse. So the hypotenuse will be 9 divided by cos 60. So on my calculator, that's going to be 18 centimeters. And then to find the third side, it's probably easier to use Pythagoras, which tells me that 18 squared, take away the 9 squared, gives me the opposite side squared. 18 squared, take away 9 squared, gives me 243. So if I square root the 243, I'll have the opposite. So the length on the third side of that triangle is going to be 15.6. 15.59, I'll leave it as. Okay, so now that I've got all the information on triangle A, by using these two steps here to find the missing sides, I can go through similar steps for each of my triangles to find the missing sides and the missing angles. So I'd use Pythagoras so that I could find the hypotenuse here. The hypotenuse is found by adding 18 and 9, and then square rooting that total, and that comes out as being 20.12. So straight away I can see that these two are not congruent, and I'm not going to worry about the angles. In triangle C, I can use Pythagoras again. I know that the 18 and the 9 are matching there, so is the 15.59. So C, side, 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 is my reason. And it's going to be A and C, but I just want to check D. So if I use that 60 degrees, the 18, and I want to find the hypotenuse, opposite, hypotenuse, I'd be using sine. So sine of 60 equals opposite over hypotenuse. Hypotenuse equals 18 over sine of 60. The hypotenuse comes out as being 20.8. Yeah. So it's definitely A and C. So here, A and C, 3 matching sides. Proves congruency.